Alright, so the next thing I wanted to show you guys is an example of how we can use matrices to solve a problem that you've probably seen before and solved by trial and error. So the example is chemical equilibrium. And let's just take as the example CH4 plus O2. So this is the combustion of methane into carbon dioxide and water. So you're pretty familiar with this. However, as it stands right now, we don't have, they're not balanced, because you see we've got 4 hydrogens over here, we've only got 2 hydrogens over here, we've got 2 oxygens over here, and we've got 3 on this side, so it's obviously not balanced. So what we have to do is we have to find out what the coefficients of this is. So let's denote it as x1, x2, x3 and x4, and let's see how we can use our knowledge of matrices in order to work this out. So the first thing we do is we write out for carbon how many elements we have of that for each variable. So we've got 1 carbon here for the x1 variable, so we can write 1 x1, and on the right hand side here we've got 1 in the x3 position, so that's going to equal 1 times x3. Let's do the same for hydrogen. We've got 4 here for x1, and we've got 2 over here for x4. Let's try that for oxygen as well. Oxygen, we've got 2 for x2, we've got 2 for x3, and we've got 1 here for x4. Alright, so let's try and write this out so that well, the first thing we know is that we've got to have the masses have all got to add together to give 0. So basically we've got conservation of mass, and conservation of mass means that the mass of the products minus the mass of the reactants is going to equal 0. And so that's what we're expecting. We're expecting that we're not creating any mass and we're not destroying any mass. In this reaction we've got mass conservation. So let's rearrange these equations here into an equation where we've got a whole bunch of variables on one side and we're equating that to 0, because that's what our mass balance says. So I've got a column here of x1, x2, x3 and x4, and down here I've got carbon, hydrogen, and I've got oxygen. So for carbon, I've got 1 in the x1 position, I've got 1 in the x3 position, and I've got 0 and 0 in the other positions. For hydrogen, I've got 4 in the x1 position, and I've got 2 in the x4 position. Okay, so I've got and these are 0 and 0. So I've got 2 in the x2 position, and I've got 2 in the x3 position, and I've got 1 in the x4 position. Now the next thing I have to do is I have to move these over to this side so that I can equate this equation with 0. And so basically what I'm doing here is just shifting these values over here. So if I was to shift this over, I'd have 1x1 minus 1x3 and that would equal 0. And so you can see that by bringing all of these parameters over to the left, we can equate this whole thing to 0. And so basically when I do that, everything on the left hand side here becomes a negative, and we can equate this whole thing with 0. Hopefully that makes sense. And so now we've actually got a matrix, which is very cool. And the matrix times the column vector x1, x2, x3, x4 is got to equal 0. So we've got to find out what these here are. So what I'll do now is I will, if you were to row reduce this matrix here, what you'd end up with is the matrix 1, 1, 1, 0, 0, 0, 0, 0, 0, negative a half, negative 1, negative a half. And because we're actually got the equation ax equals 0, then we don't need to worry about this term over here, because we're just trying to find out how to row reduce this matrix here. And so what we've done is we've row reduced it to this equation here, and we've got x1, x2, x3, x4, and that's going to be equal to 0, 0, 0, 0. Alright, so the next thing to do is to put this back into the algebraic form. So what we've got up here is we've got x1 is equal to x1 minus a half x4, because remember what we're doing is matrix multiplication, so we're taking the first row and we're timesing it by the first column, and so we've got 1 times x1 and we've got negative 1 over 2 times x4, and so we can rearrange it to give us this. We've got x2 minus x4 is equal to 0. We've got x3 minus a half x4 is equal to 0. Alright, so the next thing we're going to do is we're just going to choose a value of x4 for which this holds true. Now, the reason why we don't have one single solution is that in reality we can have any multiple of x4 and this will actually work. And that's because, you know, you can have multiples of the same balanced equation and it means exactly the same thing. And I'll explain that a little bit more later on. So what we can do is we can rearrange this. We can move these negative values onto the right hand side by adding by that same value. So it's x1 is equal to a half x4. We've got x2 is equal to x4, and we've got x3 is equal to 1 over 2 x4. Okay, well, because we've got fractions here, it makes sense for us to choose our x4. I mean, we could choose anything, right? But let's choose it to be 2. And if we choose it to be 2, then it will mean that we don't have a whole bunch of halves, which gets a bit ugly. So if we made x4 equal to 2, then our x1 is going to equal a half of x4, so x1 is going to be equal to 1. x2 is going to be equal to x4, which is 2. And our x3 is going to be equal a half of x4, which is 2. 2 divided by 2 is going to equal 1. And so let's put this in. So our x1 is going to be 1, our x2 is going to be 2, our x3 is going to be 1, and our x4, which we chose, to be 2.